What we are today comes from our thoughts from yesterday, and our present thoughts build our life of tomorrow. Our life is the creation of our mind. Those are the opening lines of the Dhammapada, sacred Buddhist text, the words of Buddha himself, who summarized this by saying, "We are what we think." 2.5 millennia later, after the Buddha's words, quantum physics has verified the fact that we are what we think. Futurist Willis Harman said that the fact that we create our own reality was the most important scientific discovery of the 20th century. More has been learned about the brain and the mind in the 1990s than in the entire previous history of psychology and neuroscience. Every thought we have produces a biochemical reaction in the brain. So be careful what you think. It's not like this is a Word document, our brain, and if you make a mistake or say something you didn't mean, or even think something that you didn't mean, that you can go back and delete it or cross it out. It's there. It's become part of your brain and has created a biochemical reaction. So just as we should always think before we act, we should really think before we think. And that's not as easy as it sounds, because our brains like to indulge in what they feel like doing, what they're used to doing. The brain is a creature of habit. It's as if the mind were a pure tissue, a clean slate that we start with. And over time, we use it, we soil it, we crumple it up, we use all those bad habits. Well, wouldn't it be nice if we could torch that mind away and just create something new and playful? Transformation is possible, and it's not all magic. In a recent study with Black and Hispanic students who had scored significantly lower than white students on an achievement test, they gave them a 1-hour lecture about the powers of the brain, how the brain worked, and explained to them by using brain exercises and focusing that they could actually become smarter and achieve more. Then they retested them after just one-hour lecture explaining this, and they cut by more than half the difference in the achievement level on those same tests, just with believing that they could make themselves smarter. In the 1980s, using some of the new technologies, there was one of the breakthrough studies on the idea that the brain can or cannot create new nerve cells. And it was performed by a scientist named Fernando Nottebohm. He was fascinated with songbirds. As you know, most songbirds sing the same old song all their lives, same mating routine or whatever it is they use, except for a few. There's a few kinds of canaries, finches, chickadees that are very adept at memorizing songs, and some of them, like male canaries, learn a whole new repertoire of songs every spring. And Nottebohm was fascinated by this. So he wired up the birds and did a study of their brains. And the part of the brain, which was a large part in the bird, that was responsible for the songs, doubled in size in the spring when they were learning their new songs. And then in the fall, when they'd kind of let them drift all away and forgot them all, it shrank back down to its normal size and would double again in the next spring. Neurons don't divide like the rest of our cells in our body. We produce new cells all the time because they keep dividing, but brain cells don't do that. However, what we now know is that we have a store of stem cells, neurostem cells, in the brain, and we actually create and grow brand new neurons. And when we stimulate the brain and think about them, we make new neurons grow. And it's not only when we actually do something, it's also even when we think about it. There was another very interesting study done with piano players, and they had 3 groups. They gave one group an exercise to do playing the piano. They worked for several hours every day doing these same exercises. They had another group that was a control group, and a third group who was given the exercises, explained them, and told to spend the same amount of time as the piano players, but to just go over it in their mind and think about playing the piano, but they actually never touched a piano. Well, the piano players showed a 30% increase in the region of the brain responsible for piano playing in compared to the control group, which had no change whatever. But the other ones who were just thinking about the piano actually had a 22% increase in the size and activity of their brain in that region. So it showed that just thinking about doing this was almost important as playing the piano ourselves. So how do we make this breakout, though? How do we get out of the cultural morass we're swimming in and do something about the state of our brains? Well, for one thing, we need to change those habits. And I think a good piece of advice for changing habits is to evolve beyond habits. We now know in integral evolutionary theory that evolution socially and psychologically happens by including and then transcending a certain level of understanding. It doesn't reject. What we did or thought or anything in the past is not wrong, it's just we're going to a higher level. And likewise with our habits, don't make a self-sacrifice. Don't say, I'm not going to do that and I'm really going to suffer because I really love to do that bad habit. Include that bad habit and transcend and find a higher, better habit to replace it. That's how evolutionary theory works, and it helps our mind-brain togetherness understand and make it feel better about breaking habits. But we also have a part of the brain that can really help us out in this. The frontal lobes. And that's these 2 parts of the brain right here, right up in the front of our neocortex. The frontal lobes are what makes humans human. In human beings, the frontal lobes make up nearly 40% of the neocortex, or the gray matter up there. In dogs, it's about 7%. In chimpanzees, which are closest to us, it's about 10%. So our frontal lobes are nearly 4 times larger in proportion to our already larger brain than a chimpanzee's. And what's so special about the frontal lobes? That is where we get our sense of self. That's the part of the brain that generates will, intent, reason, planning, anything you're going to do about yourself or change your life, it activates the frontal lobes. So we've got to put those frontal lobes to work, to break habits, to move on, to evolve. And that's pretty hard too. There's a fascinating book called Evolve Your Brain by a man named Joe Dispenza, and he said the biggest reason most people cannot utilize the frontal lobes is because we are addicted to our emotions and feelings. In a very real sense, we have self-lobotomized our own brains solely on the by relying solely on the hardwired, oft-repeated neural networks that require little or no thought to initialize. Unless we break out of this sacred habit of ourself, we are destined to endlessly repeat the same cycles, going down those same old muddy, rutted roads, the same old path through the snow, because that's the easy way. Our brain wants to do what it's used to doing. It's our mind that has to say, brain, we're going to build a new self. We're going to put the frontal lobes to work, and we're going to change you. And to do that, you can do mental rehearsal. You can decide, I'm going to be a free-thinking genius in the future, for example. Well, the minute you say that to yourself, your frontal lobes go crazy. It's like, oh man, we got to get information from everywhere in the brain. This guy wants to be a free-thinking genius, or this woman, or whoever. What do we remember here and there? And it just bursts into activity to try and figure out how to do that. And you can rehearse that over and over again. And as we know from the piano players, rehearsing it and thinking about it is almost just as good as actually doing it. So, to begin with, we need to think about it, we need to visualize something, and we need to start rehearsing it in our own brain. Another thing we need to do with those frontal lobes is pay attention. We are bombarded by thoughts. 400 billion bits of information are bombarding our brain every second. We're able to handle about 2,000 of those bits consciously. So obviously we've got to filter out a lot of stuff. So be very selective about what you pay attention to. In another brain study with monkeys, they wired them up and all the monkeys were receiving sensory inputs on their fingers and in their ears with sound. And half the monkeys, when the rhythm changed on their fingers being touched, if they pressed the button, they got fed. And the other half of the monkeys, when the rhythm in the sound or music they were hearing changed and they pressed the button, they got fed. But both monkeys were receiving the same sensory inputs the whole time. Well, after a month or so, in the group of monkeys that got fed through the finger tapping change, that part of their brain had grown and responded tremendously. And those who got fed through the sound change, that part of their brain had changed. But they'd both been doing and hearing the same thing. The only difference is, what were they paying attention to? That recorded in their brain. So even if you're listening to a nice lecture about brain theory, if you don't pay attention, then it's not going to do your brain much good. And likewise with everything you do in life, if you go out there, be into it. Be the sort of Zen now and pay attention, and that's where those frontal lobes really appreciate the effort of paying attention. In World War II, they were doing a study on brains to determine what kind of pilots they wanted to have flying dangerous missions over the South Seas. And like in most of our intelligence tests, they were really concentrating on these left brain capacities. That's where you get the IQ test. Up there. Can you get the answers right? And so they took all these really intelligent pilots and they sent them out to war, and what they found out was the first time they got in a tense, difficult emergency situation, they pressed the eject button, they lost the plane and probably the pilot too. And they thought, we need to find pilots who use more creative thinking. And this led to the theory that the left brain is responsible for convergent thinking. It screens out everything else and breaks it down and focuses on one thing. Okay, I got the answer, the eject button. Okay? The right brain is the creative ocean of all opportunities out there. And it's going to say, wait a minute. Before we do that, let's think of everything else we can possibly think of here to find some other solution. So, give your right brain a break. Again, our culture emphasizes left brain productivity. Our achievement tests, our educational system is really heavily left brain focused. And all that creative potential is sitting over here, often unused in the right brain. And as I said before, we are bombarded constantly with all these bits of information, and so we have to filter it out. And the brain has something they call latent inhibitors, which really blocks out all the information we don't need. Well, what happens is that we usually block out most of the right brain's potential and just focus on an answer or a given thing. So break down those latent inhibitors. Open up your right brain, and that's where your creative field of potentiality really resides. In doing something like this, you can reprogram yourself for whatever you want to be. It's residing out there in that right brain somewhere. But it's not still all that easy. You know, as Thomas Edison, the author of 1093 Patents, said, genius is 1% inspiration and 99% perspiration. But you do need that 1% to think of the idea first before you set to work on it. And then once you do, keep at it. Mental rehearsal, time and time again. As Aristotle said, we are what we repeatedly do. Excellence, then, is not an action, but a habit. So now we begin to see we haven't rejected our old habits. We've opened up the right brain. We've seen some creative potential. We've made a proposal to ourselves, and now we're going to mentally rehearse it. And suddenly we're moving to beyond higher, better habits. But we're still swimming in this culture. How do we clean out the clutter of culture and environments in our brain? I mean, it's one thing to say, okay, I'm going to do this. I'm going to really put my brain to work. But, you know, we're still products of our culture, our surroundings, where we live, everything else. Well, improving your environment also aids neurogenesis. Neurogenesis is the creation of new brain cells. In a study of mice, they had mice just in a normal barren cage and another set of mice who had a running wheel and playthings and little tubes to run through and all this. And at the end of a month, they scanned the brains of these mice, and the ones in the normal cage, their brains hadn't changed at all. Maybe they'd even deteriorated a little bit. The ones who had all the playthings, their brain had 30% better capacity and more activity going on. So the next time you've got a running wheel or a treadmill there, take advantage of it. No, but what it shows is that the environment, what we see, what we do all day long is also having a constant biochemical impact on our brains. And it is all about lifestyle. One of the most interesting, foremost neuroscientists in all this research is a gentleman named Fred Gage. And when they were asking him about, you know, all the new drugs to treat illnesses of the brain and cell replants and all this fancy technology, he said, you know, the best way to augment brain function doesn't involve drugs or cell implants. It's about lifestyle changes. Diet, proper sleep, enough aerobic exercise. And it really does make a difference. And as we begin to work on these lifestyle changes too, it generates these stem cells, and they actually do grow. And it creates a positive feedback loop now that rather than a deteriorating brain and a same old habitually driven environment, we're suddenly out there generating new brain cells with new ideas and improving our environment. Another thing that we can do is to travel, to get out of our environment. Now, I know it might help to go off to the South Seas and lie on a beach and sip margaritas or something. We can't always do that all the time, but I would encourage you, and at the Center for Culture Interchange, that's what a lot of our cultural exchange and ideas is about, is to get people to travel and experience different cultures, because the minute you do live in another culture, you understand that perhaps your culture wasn't all that right all the time. But if you can't travel physically, you can travel in your mind. You can travel away from your safe space and go to somewhere special. Right here in Chicago, you can go down there to the Jelly Bean and look at that distorted image of yourself, and it kind of looks like a brain or whatever, and you can have a whole mind experience right there instead of sitting at home eating popcorn and watching the same old scary movie or something. So travel away from your safe space, whatever that means. But make yourself do it. Your brain will appreciate it, you'll have more fun, and it'll again be this positive feedback loop coming back to you again. Well, as we're changing our lifestyles and moving along and trying to evolve a higher brain, maybe we can even pursue things beyond a normal life. And all joking aside, we're not going to become free-thinking geniuses. We could aspire to more joy, happiness, and compassion in our lives. And there have been studies on this as well. Last week, just in time for Valentine's Day, I read an article about a study they did on kissing. And they had a control group that just held hands. And then they had the lucky group that got to make out for 15 minutes. Preferably with someone they enjoyed, It wasn't random choice, okay? And again, they ran the brain scans on these people. And after just 15 minutes, the people who had been kissing showed a dramatic decrease in cortisol, which is this biochemical in the brain that's basically responsible for stress. And so, whereas the handholders had almost no change whatsoever. So, Valentine's message, well, read between the lines. But, and there are other things on this idea of love. Along with the idea that the brain doesn't grow after we're 20 or something and it's all downhill from there, psychologists have also been very fond of saying, well, the same thing happens with love. And in partnerships, when there's that new, really strong emotional love, psychologists call this limerence. And the standing theory was that limerence will wear off usually between 10 and 15 months after a relationship is developed. And then basically, like our poor brains, it's kind of all downhill from there. And after 10 years, there's nothing left there. Well, fortunately, there's been another study on this as well. And they've done it with couples who've been together for many years. And again, with brain scans, they can discover these degree of biochemical actions in the brain. And they found out that at least 10% of people are capable of maintaining that limerence, that relationship, 10, 20, 30, 40 years, for as long as they want to do it. It's within our capacity. Now, I didn't really need a scientific study to tell you that. I can, from my own experience, I know it's true, and my wonderful relationship proves that limerence lives long, but for those of you who are maybe not all that fortunate all the time, just remember that love is love and not fade away. But we can find love, we can keep love, and we can even seek true love. But what might true love be? It's something beyond the emotional excitement of limerence, that's for sure. And the Buddhists have some thoughts on this. They think it has something to do with compassion. And probably the most fascinating study of all that I've read about brain scans is one conducted by Richard Davidson at the University of Wisconsin. And he managed to get some of the most adept Buddhist monks in the world, brought them back here from Tibet, wired them up with 256 electrotransmitters on their brain, and asked them to do compassion meditation in his lab. And then he took a control group of University of Wisconsin students, and just to be fair, they gave these students a week lesson in compassion meditation so that the students knew what they were supposed to be doing. But the Buddhist monks had been meditating 20, 30,000 hours, some as much as 50,000 hours throughout their lives. Well, the results the Buddhist monks blew the students away on the scores. And they showed this incredible increased activity back in our old friends, the frontal lobes. And actually, there's one little spot right down here that neuroscientists kind of call the seat of happiness. And there was one particular monk who'd meditated like 50,000 hours, and he just had this activity going on in his seat of happiness that was like double anything they'd recorded ever before. They called him the happiest man alive, and scientifically speaking, I think there was good reason to call him that. And what happened in this monk's mind? He was emitting gamma waves. Now, there are basically 5 different kinds of brain waves that we emit. We have delta waves, which is when we're in our most unconscious state, dreamless sleep. Then after that, there's theta waves. Then in our waking state, normal active state, we have alpha waves. And finally, if we're really thinking, doing stuff, we have beta waves. And in a few key moments, 40 cycles per second, we emit gamma waves, like this monk was doing in his compassion meditation. If we put our minds to work and make our brains change and rehearse and visualize that we're going to be happier people, we'll be happier people, and it will work. In the last 36 years, there was 46,000 scientific articles written about depression and less than 400 on joy. So again, maybe it's a cultural problem of our neuroscientists. Maybe we're too locked in to worrying about the downside and not engaging our frontal lobes in investigating the future with the brighter, happier outlook. So, if we have those special moments and we emit those gamma waves, how can we make that happen, though, other than doing 50,000 hours of universal compassion meditation? Well, gamma wave signals happen in the brain under other circumstances, too. Primarily with a perceptual shift, an aha moment. I'm sure we've all had one of those. When suddenly we get something, then we have gamma waves. These cubes, for example, if you look at them, you can see them in 2 different ways, sort of one way or inside out. Top line there on this cube on the left, it can be either the foreground, or if you look at it, the background, and that other line is the foreground. So whichever way you looked at it first, study it a while, and the minute you see that cube shift, your brain emitted some gamma waves. So we need to find perceptual shifts in our brains. That's what we're looking for. And it kind of makes us happy. When you see it, you go, oh, that's cool. Yeah, right? I get it. So here's another example. Now, I don't know if you see an old man, a young woman, or an older woman there, but it kind of depends on how you look at it. But they're all 3 up there. On the left, there's a profile of a young woman with her nose and an eyelash. Then down here, there's the mouth and mustache and nose of an older man. And then there's an older woman here, and this is her little mouth there, and her eye is the same eye as the old man. So as your mind shifts back and forth between those 3 images, you're emitting gamma waves. You're having a perceptual shift, and frontal lobes get all excited about that kind of stuff. So to make gamma waves work, to make our mind work, it takes some technology. Maybe it even takes a little magic. Science fiction writer Arthur C. Clarke said, "Any sufficiently advanced technology is indistinguishable from magic." And we now have the magic to do some of these things. We have the knowledge that we do produce new neurons, that we can program our mind, that we can have perceptual shifts, that we can get out of our culture and our environment. And actually, we do have this freedom to create our own reality. We use the left brain to do our cognitive rational thinking and our right brain to access the creative field. And we put them together like two hands to create a work of art, little by little, molding something throughout life. Maybe we can create slowly, like the potter's wheel, as if it were all those perceptions running through our brain. And if we've got two hands on the piece of art there, maybe we can mold a brain into something truly fantastic. So, every thought we have creates a biochemical reaction in the brain. We are what we think. The Buddha was right. We are the products of our own minds. And if we take that tenet seriously and we adapt it to ourselves, we can mold and create the most beautiful works of art ever made inside our own heads and put them to work in our own lives. It's as if the mind were an open, clean, slated tissue. And over time, we soil it, we crumble it up, we cause all kinds of problems to that poor brain. But wouldn't it be nice if we could transform it, if we could make something happen, create some aha moments, and spread gamma waves to all of you. Thank you.
To retrieve it, it will fall off the shelf.